Big data, IoT, AI, these are buzzwords that we all work with, we know quite well. But we all know that all of these are driven by, all the aspects that we work on are driven by business cases. And today I'm here to speak about a few business cases that we at Bosch have been working on, which relate to big data, IoT, and AI. So before we get into the use cases, I wanted to set the context. Why has IoT today become so prevalent? It's primarily because of the number that you see on there. We have nearly 26 billion IoT devices, discounting the laptops, smartphones, or the other or PCs that you would have. We'll have nearly 26 billion devices which will be IoT driven by the end of 2020. Now these are getting used in a variety of places. There are sensors that are actually used in industries. So these sensors track everything from temperature, vibrations, to also tracking electricity consumption for all the machines in a plant. There are Amazon Echoes or Google Homes that we use in our houses. There are also a variety of sensors that actually, and IoT devices that go into your car, what we term as mobility, which help you actually reach the level 5 for autonomous driving. So these are the things that have been driving the adoption of Internet of Things today. And with so many devices that are currently connected, 26 billion of them by 2020, they are generating huge amounts of data. And we know that nearly 90% of the data today was created 2 to 5 years back. Now, all of these devices that are actually currently functioning, especially in the industrial area, the sensors that have been around for years. We've been using them for condition monitoring, where we've been taking data from the machines in the plant and using them to do preventive maintenance. Wherever we actually see an error occurring, we go correct it. If we see a particular machine that is actually processing output incorrectly, creating scrap, we correct it. But today we are actually moving from preventive to predictive maintenance, where we're taking all the data that is coming from these sensors, nearly 26 billion of them, of which a particular percentage is used in industries, to actually improve the functioning of plants, improving the efficiency in plants. Now, most of these 26 billion devices that are going to get connected are generating nearly 40 trillion GB of data by the end of 2020, and this is just going to grow, which is why IoT is very tightly coupled with big data. Now, what has actually caused this? It's basically because sensors have become less expensive now. We have better computing power, and we have better storage, which is all less expensive. And all of this has actually been enabled by the prevalence of 4G, and 5G is going to actually have a very big impact on the industrial side pretty soon as well. So internet connectivity is improved. And these aspects have enabled IoT to actually become all prevalent today. Now, with the prevalence of IoT, with the amount of data that is getting generated, we need to utilize that very effectively, take decisions very quickly. To give you a background of why Bosch as an organization is interested in this. So I think most of you know us for our dishwashers and washing machines. Probably some people know about our power tools. But primarily we are an automotive component or company. So every car that you see on the road, there are at least 10 components from Bosch that go into that car. Along with that, we also work on hydraulics as well. So the Tower of London, the Tower Bridge in London, the London Eye, all have hydraulics from Bosch, and all of these have sensors in them, which actually generate a lot of data. Manufacturing these components are 270 plants worldwide of Bosch, which is the reason why we are really interested in ensuring that we are taking in the data from all these sensors and using them appropriately. In fact, another statistic that I'd like to tell you about is the fact that Bosch manufactures nearly 4 million sensors every single day, and these sensors actually go into your smartphones. These sensors go into vehicles that help you detect whether there's water on your windscreen and whether wipers need to get turned on. These go into the ECUs in your cars. So all of these developments have led Bosch to realize that we need to be IoT focused. In fact, the words of our chairman of our board is that we are going to be less a product-driven company and more an IoT company in the future. And that's why IoT and big data are really critical for Bosch as an organization. Now, having set the context where we realize that IoT is really critical, we are generating huge amounts of data from the IoT devices that are connected to machines and plants, that are connected to cars on the road, that are connected to your dishwashers and washing machines as well. What are some of the use cases that we can actually think of which relate to these IoT devices? I thought I'll actually cover 3 specific areas today, areas that people probably know Bosch for, such as manufacturing. So I spoke about 270 plants. So we need to improve the productivity in each of these plants, and that's one of the reasons why we are working on some use cases on the manufacturing side. Next is on the mobility, which is in the vehicles. So autonomous driving, electrification. We have sensors that actually drive each of these IoT devices that drive each of these aspects as well. And I'd like to speak about a few use cases in the mobility space as well. And I thought I'd pick a third area, which is probably not something that people associate Bosch very much with, which is agriculture. And we've done some really interesting use cases on IoT and big data there as well, where we've probably used sensors in soil to detect the moisture content in soil. We've actually looked at noise that is getting generated from farm vehicles, and we have actually predicted yield in a particular farm based on that using big data. So I'll speak about a few use cases out there as well. So to begin with, manufacturing. So let's take the example of a manufacturing plant. Now, the biggest bottleneck in a manufacturing plant are the test stations. Every manufacturing company in the world wants to deliver really high quality products, and that's very true of Bosch as well. And we really want to ensure that these test stations don't act as bottlenecks. What we did was we actually looked at all the necessary tests that we performed on specific components in a plant, and we identified which are the ones which give the right type of accuracy. So we did clustering, we applied certain other techniques, we ensured that we looked at the end of line data to predict which tests actually figure or identify the right type of errors that occur in the devices that we are manufacturing. Once we did that, we eliminated nearly 23% of the tests that we were actually doing. So this reduced the bottlenecks considerably. So that's a 23% reduction in time for testing, which freed up 23% of time for the entire plant to actually function for longer. So huge amount of savings that we were able to generate just by doing, let's say, end-of-line checks, identifying which test cases worked well, and just optimizing the test cases that we would run. We extended this. We created a manufacturing analytics platform. We had the test time reduction, which was nearly 23%. We stuck to that. In addition to this, we also started looking at other areas which would actually give benefits within the plant. For example, scrap. So we looked at the amount of scrap that is actually getting generated in the plant. All of this is happening because maybe the alignment in a particular machine was incorrect, or the tolerance limits are getting exceeded. So these aspects were actually tracked through sensors. We actually tracked the tolerance limits, we tracked the alignments through sensors, and all of this data was actually brought back into our repositories. We did analysis on that. So these analysis could be things like group lasso. There were correlations that we actually ran. and at the end of that, we came out with an understanding of what should be the right alignment, and this would then get triggered real time to the shop floor worker to take a decision on whether the alignment is correct, whether he needs to make a change or not. So another area where IoT devices work well with our big data capabilities to reduce scrap costs, and this reduction was nearly 65% of the baseline of scrap that we had in the plants. So all of these single use cases that we've actually driven has actually reduced the cost or improved the bottom line by nearly 200,000 pounds at the very least for each of the use cases. And I'm just speaking about the 2 use cases at the event here, but if you want to speak about some of the other use cases that we've done, especially in the area of electricity monitoring for devices or sensors that actually do preventive maintenance in the plant, those have reduced quite a bit of cost for us as well in every process. So moving on from manufacturing, the next aspect that I'd like to speak about are cars. Obviously, all the cars that we have today are probably more complex than the computer systems that we have. In fact, the number of lines of code that are there in a vehicle are actually higher than the number of lines of code that you have in an operating system today. And there are so many different sensors in a car. There's a fuel sensor. There are sensors on for transmission. There is a sensor on your windscreen to detect water. There's a sensor inside the car to detect the temperature that you're at. There are sensors on your battery, especially with electrification coming into the picture. That becomes very critical. So all of this makes a car a very, very complex piece of equipment, which is generating tons of data. And all of this data is actually getting collected by a variety of people. This could be the auto OEM who sold the car to you. It could be your roadside assistance company whom you actually contract. You could probably be working with the AA. They would have given you an onboard dongle, which will actually track the amount of the data coming out of your car. It could be tracking how well your car is doing, whether it needs to undergo a service, or it could even be tracking how well you're driving, whether you're pressing the brakes too hard or whether you're accelerating too hard out of a corner. So those are aspects that that's the type of data that all these people are collecting. In fact, we've been working not just with OEMs or with roadside assistance companies, but we've been working with insurance companies as well. We've been having conversations with them where I'm sure they actually give you some devices which, if you put in your car, they actually they would reduce your premiums for that, for your insurance, right? So all of these different organizations collect data from the vehicle. They process them and then they make complex decisions on them. So they can provide better service to you. So a roadside assistance company can provide better service to you by predicting when your battery is about to fail. In fact, nearly 70% of the roadside assistance calls that most of the roadside assistance companies get is for a failure of battery, and they can usually predict that by the telemetry that actually comes from the car. Insurance companies can actually provide you better premiums if you are a safe driver and if you've actually driven very well. They can even process your claims much faster because they know that you are not the person who's actually caused the accident, but it's been caused by somebody else. So those are the type of services that can actually come out of it. In addition to this, OEMs can actually improve the design of the car over a period of time. They take a lot of the data in terms of how well people are driving, what sort of conditions the car has experienced, whether the braking system is working fine in wet conditions or in the wintry months, whether it needs to improve. So those are aspects that actually feed back into the R&D department at an OEM, at an automotive OEM, and they can then improve the quality of the vehicle that we actually get. So a variety of services that can be offered based on all the data that is getting generated through all the sensors that are there on the car. And all of this is possible because we are taking, I'd say, several GB of data per car every day, which is the amount of data that's actually getting generated from the sensors, and then processing that for the services that we are offering. Now, what are some of the examples? I did give a few examples, but driver assistance system are examples. Is a very good example of how the automotive industry is working well today. So, if you take let us say the autonomous driving, there are different levels that we actually look at. Level 1 is the lowest level, where you have basic traction control systems that go all the way up to level 5, which is a completely driverless car that can actually drive by itself. So we are working on driver assistance systems, doing tests even here in London, where we are doing correlations, analyzing the data that's coming out of when the car is being driven manually, when a particular person is driving, when they actually brake, what are the aspects, or what are the surrounding objects, whether there is a person in the surrounding area, in the vicinity, whether it is an immovable object, whether it's a bus that's actually coming onto the road. How do people actually react to that? And we correlate that to the autonomous driving algorithms that we have. And based on this, we take decisions on how driver assistance systems should be developed. And these driver assistance systems are not just going to work at level 5, which is completely autonomous, but they would work at level 3 or level 2 of autonomous driving as well, which will enable you to drive a car better, will cause lesser accidents on the road, will improve the consumer experience overall. So those are some of the use cases that we actually utilize the data from vehicles for. The other place where we use a lot of data is also on the powertrain systems. So these are electric powertrain systems. So the entire world is moving towards electrification. Elon Musk and even larger companies like BMW and Ford are actually looking at electrification in a very big way. Some of the key aspects that actually impact us are, how do you charge your car now if it's electric? Because there need to be electric fuel forecourts, which should be available at various places across the country for you to be able to charge your car. That's actually been a big challenge in terms of adoption. And once more and more fuel forecourts come up, there will be a lot of questions with not just the auto OEMs, but also the people who are providing these electric forecourts, to understand what should be the cost of the electricity per unit, because electricity is going to become the most important commodity. And those are areas where the charge spots and the ability to actually price appropriately is done. And that requires a lot of data analysis that we are actually doing currently. We have systems that help in electromobility, which take into account the amount of electricity that's getting consumed based on driver behavior, and provide the right pricing for charging as well, which is also very critical. Some of these are obviously being prototyped currently, but something that will become very prevalent or ubiquitous in about a year or two. Finally, warranty diagnostics is a very critical aspect, probably for us as consumers, because when you're driving a car, you want a good experience. I know of a few friends of mine who've actually stopped buying or stopped utilizing cars from a specific auto OEM because they actually fail very regularly. So even though the costs of warranties are about 5%, about 50 billion out of the total $2 trillion dollar car industry every year, the price in terms of customer satisfaction is actually much higher for most auto OEMs. So we've actually done a lot of analysis, a lot of data that comes from onboard devices from vehicles, and we look at nearly. So this is a project that we did for a specific auto OEM, where we looked at nearly 43,000 global vehicles across the globe, and we looked at huge volumes of data that are coming out of these 43,000 vehicles, and we applied algorithmic association, and we discovered what the cause of the warranty failures were. This led to the automotive OEM actually changing certain suppliers at times, In another case, they actually were able to predict a particular failure pattern for a specific battery related issue, which they were able to ask consumers to change earlier. They were able to do some recalls a bit earlier as well, so that there's no so that they don't actually get bad publicity if there are failures on the road as well. So it's not just the 7% reduction in cost that people find attractive, but also the benefit that they get from the improved customer experience. So these are some of the use cases that we've done or we've worked on in the mobility space. Now, to speak about some of the interesting aspects that we've been working on in agriculture. There are three use cases that I like to speak about, but the first one is something that I find very interesting, because we've actually used drones to identify when fruit is ripening in a farm. So drones actually fly across the blueberry farm, based on the shape, the size, the color of a blueberry. We are able to predict which are the parts of the farm which actually need to be picked at a particular point of time, and this is done through machine learning algorithms, because obviously and the image detection that we have, and the yield estimates for different parts of the farm, because this is a 100-acre farm that actually spans several fields. It's not a small farm per se. So obviously you need to be able to figure out which part of the farm you're going to pick at what points of time, and this helped us in identifying the right parts of the farm to actually pick at the right time. So helps in harvest planning, helps in looking at the yield that's coming out of a particular farm at a particular point of time, and really helped in automating the process as well. One of the other things that we're working on is also how do we automate the berry picking, but that's probably a conversation for another day. But image analytics helped us in picking berries through machine learning algorithms, and improve the yield for farms. The next use case is soil sensing. So this is improvement of irrigation in the farms by sensors that we put under the soil. Also, we used microwave satellites to detect what the quality of soil is. We did a correlation between the data that's coming out from the sensors across the farm, and also the image that we were getting from the microwave satellites. And this would then feed into the irrigation system that the farm had, giving a view in terms of which parts of the farm need to be irrigated at what points of time, how much water needs to be released. And this was used in a sugarcane or a beet farm, and it's very critical, because the loss of a particular portion of the farm is really impactful, because it reduces the yield, and it causes nearly 40 to 50% of revenue loss for the farmer, primarily because they were not able to predict the right amount of water to be released to the farm. So, decision support system for soil irrigation based on sensors. Finally, the last use case is the one where we used sound analytics to detect how well a particular farm is being utilized. So we automated the farm monitoring. Instead of having people actually go and check how well a farm is being plowed, or how well the workers are working in a particular farm, we put in sound sensors on each of the farm equipment, and based on the sound patterns that we are getting from the equipment, we were able to detect the utilization. We were also able to correlate that with the GPS from the farm equipment to figure out which parts of the farm have been irrigated, or which parts of the farm have been plowed properly, and this helps in ensuring that we have an understanding of the farming behavior, and not only just the farming behavior, but also to be able to monitor the asset. So if a particular tractor is about to fail, we can actually predict that in advance, because we are monitoring the sound. We know when what type of pitch the sound should have if the failure is about to happen. So 3 use cases in the farming space. Now, to end with, I'd like to quickly speak about the type of industries that we're working in and the type of work that we're doing. I did touch upon the effort that we put into bringing IoT and AI together. And we're working in the areas of smart living, energy, retail, obviously mobility, and our industrial plants are aspects that we cover in any case. But not only do we use AI and IoT, but we are also using distributed ledger technologies to identify provenance of data, especially in the area of agriculture, where we check what the provenance of a particular, let's say, sugar cane is, or what the provenance of milk is, based on the IoT devices that we are using. So these are aspects that we work on. We are trying to find intersections, and mostly it is driven by use cases, as I said at the start of the session. So we are driven by use cases, although we use AI, distributed ledger, IoT, big data. It's all driven by use cases. If you want to speak about any of these use cases, please feel free to come up to the Cloudera booth and speak to me about it. I'll be there all day. Thank you.